right, so our first method is the one method on the test where you're going to have to find your total population, standard divisor, standard quota. So, and that'll be done with the Hamilton one. So in this case here, we have to add up every single individual population. When you add that up, you get 3,225 total people. Okay. And then you take that total population and you divide it by the reps. So 3,225 divided by 60. And that gives me a standard divisor of 53.75. Everything we round will be rounded to the nearest hundredth. Now we take each individual population and we divide it by 53.75. So 273 divided by 53.75 is 5.08. 426 divided by the same number, 7.93. 375 divided by that same number, 6.98. 196 divided by that same number, 3.65. 701 divided by that same number of 53.75, 13.04. 341 divided by 53.75, 6.34. 89 divided by that number, 1.66. And 15.33 is my final standard quota. So now, lower quota, upper quota, and initial apportionment. We'll all do it one step. The lower quota is the number in front of the decimal point. The upper quota is one number bigger. And we write the lower quota in for the initial apportionment every single time. This is 7, 8, 7. Lower quota here is 6, 7, initial apportionment 6. 3, 4, 3. 13, 14, 13. 6, 7, 6. 1, 2, 1. 15, 16, 15. And that is what Hamilton's method guarantees. It guarantees you nobody gets less than the lower quota. So you're never going to have lower reps than your lower quota. But with Hamilton, you never get more reps than your upper quota. That's how he kind of keeps the bigger populations down. Okay, so my lower quota is the fewest amount of reps I possibly can have. Now I need to add up the lower quota column. It's 56. I like to add up the upper quota column as well, just to kind of check my work. It should be 8 more since there's 8 groups. But if you add up the lower quota, 5 and 7 is 12, and 16 is 18, and 3 is 21, 21 and 13 is 34, 34 and 6 is 40, 40 and 1 is 41, 41 and 15 is 56. There's a 4 rep difference between the lower quota and the amount of reps. So I've got to give 4 reps away. And it goes to the 4 numbers that are biggest after the decimal point. 0.98 and 0.93 are the 2 biggest. So they're each going to get a vote or a rep. 0.08, 0.65, 0.04, 0.34, 0.66, 0.33. The 2 0.6s, G and D, will get a rep. And my final answer is 5, whatever my initial apportionment column says. 7 plus 1 is 8, 6 plus 1 is 7, 3 plus 1 is 4, 13, 6, 1 plus 1 is 2, and 15. My advice, I would add that column up and make sure it equals 60. 15 and 2 is 17, and 6 is 23. 23 and 13 is 36. 36 and 4 is 40. 40 and 7 is 47, and 8 is 55, and 5 is 60. Quota. So the lower quota is 7 and 11, so that's a total of 18. 12 is 30, 39, 42, 56, 66, and a total of 72, and I need to give 3 reps away. So it's pretty obvious F is probably going to be your last term. Okay, and the reason why F is going to be your last term, B and C are bigger populations. They're going to move to the next number quicker because they kind of have the head start. F, it's really between F and E, and there's really no contest. Okay, so to get my standard divisor, if I want to force this to be 15.00, because I think that's the last one that's going to go, I'm going to do 906 divided by 15. And that's going to give me a 60.4. And that's my new standard divisor. I'm going to divide each number population by that 60.4. When I do that, I'm going to get 7.55, which means my lower quota is 7. I'm going to get 12.12 here. That brings my final apportionment, or my lower quota, to 12. I'm going to get 13.39. That brings me to 13. 9 stays at 9. Oops, I'm sorry, 9 does not stay at 9. Excuse me. I got to do 586 divided by the 60.4. 9.70, that's 9. 213 divided by the 60.4. That brings me to 13.53. I would check your 906 again, but when you divide it by the 60.4, you're going to get your 15.00. 643 divided by the 60.4 gets me to 10.65, which is 10. And 6.13 from 387, that goes up to 6.41. And that lower quota stays at 6. And when you add these up now, 7 and 12 is 19, and 13 is 32, 41, 44, 59, 69, and 6 is 72. I would check that final answer each time. When I round this, this becomes 4. This becomes 5. This becomes 2. 9.23 rounds down to 9. Up to 14. Up to 4. Up to 7, and up to 11. Then I add those. 9 and 2 is 11, 20, 34, 38, 45. We get 56. So in this case, I have 1 too many. So I need to get 1 to go down. It's pretty obvious which is the last one to move up. That one right there. It's 3.52. To get it to move down, I need that standard quota to be 3.49. Remember, with Webster method, movement is based off of 0.5. Okay? So, 251 divided by 3.49, that's what's going to allow my new standard quota. 251 divided by 3.49 is 71.92. And when you divide all the others by 71.92, 3.80, 4.80, 1.95, 9.15, 984, which is going to move the quickest, but it doesn't move far enough to affect the number. We're at 3.49, 6.80, and 10.87. And from here, I round normally. We get 4, 5, 2, 9, 13, 3, 7, and 11. And we get 55. I'm rounding normally. 11, 9, 3, 17, 3, 5, 13, 17. When I add these up, 30, 35, 38. 38 and 17 is 55. 55 and 3 is 58. 58 and 9 is 58 and 9 is 67, and 11 is 78. Do I mean? Oh, I rounded wrong. Thank you. This should be rounded to 18. I apologize. So yeah, now my total is going to be 79. It's obvious which one has to move up. Which one is the closest to 0.5? It's H, and it's also one of the biggest populations, so it's going to move the quickest. I need to get H to 17.50. If I get H to 17.50, I'm good. 920 divided by 17.50. That leaves me with a standard or a modified standard divisor of 52.57. 52.57. We get 11.24. We get 9.19. We get 2.57. 17.82. 3.40. 5.25. And 13.32. And when you round those normally, 11, 9, 3, 18, 3, and 5, 13, and the 1 increase right here goes to 18, and we're at 8. And that's our answer. Are there any questions?